right, hey everyone. So the last part of this piston pump design is how we actually put together the parts and then end up going through finite element analysis to look at where it's going to break. You will notice that I'm skipping over designing the individual components like the lever arm and the linkage pieces like this. These are fairly straightforward sketch and extrude type designs, so there's lots of information online that you can find to help you get through these. We're going to focus on the more advanced parts of this pump design, including putting it together and the simulation. All right, so to put it together, the first thing we need all of our parts. As you can see, I have them here at the left. I like to keep everything in a single folder. I advise you to as well, although everyone's organization is different. And then we need a new blank file within which we're going to assemble things. So this is a new file. I will go ahead and save this as whatever, new assembly, kaboom. And then I'll start pulling in the parts. I like to start with the biggest part first. How you build it is up to you. So I'll click and drag the main cylinder in, like so. There it is. And I'm just going to leave it right where it sits in the middle there. And then next I will drag in the piston head, which is right here. And I'm just going to move this out of the way so I can see it. Right. And we're going to start building our joints. So we've got the first two pieces and we need to put this one into this cylinder. So right off the bat, I'm going to ground my cylinder. That's designating it as immovable relative to everything else. So ground it. Again, you just get that by right-clicking on the component and pulling it down to ground. Then I'm going to go to the Assemble menu and use Joint and joint the two parts together. The first one I'm going to do is this piston, and you can see I want the snap point to be the center point here of the main body. So I will click that, and then I need to click in here where it's going to be jointed. So I will put this, let's say, at the top for now, like that. And I want to make sure the motion that I've selected is a slider motion in the z-axis, like that, which it is. So I'll hit OK. Boom. And now we've got our piston head that can be pulled into and out of there. So I'm going to push it down just a little bit as I build this to make it easier. So put it there, hit OK, and anytime you move it, if you would like it to remain in that position, make sure that you go up here and hit capture position. And now that is the default starting point. Okay, so I've got the piston, I've got the cylinder. The next one up the chain is going to be the linkage here. I'll drag that in, move it over, and I want to joint this. I'm going to use the center snap point of this cylinder there, and then put it in between two faces, specifically that one and that one, at that center axis snap point. Boom. Now this is going to be a revolute joint. And there we have it. So hit OK. I will go ahead and add the pin as well. So here's, for that one, I believe I'm using the short pin. So short pin in. We're just going to position it like that. And then do the same thing, just joint. In this case, I'm going to select there and there. Boop. Like so. That's a revolute joint because it can spin freely as well. Hit OK. Right, and I'm just going up and down the chain, building it out. So the next one is going to be the lever. Right, we're going to move this over, and I'm going to swing this around so that it's roughly in the orientation that I want. It doesn't have to be perfect. Like that. And now again, joint. This is going to be one of those times where I'm using between two faces. That face and that face. And the snap point is that center point in the axis right there. And then I'm going to snap it to the center point of this axis, which, there it is, that point right there. Okay, and that is a revolute joint, so we'll hit OK and add in another pin. Now just to show you, I'm not going to orient this in the right direction. If you joint these together using the correct snap points, it should orient itself, like so. Okay. Then the last place that I need to joint together is this one to here. Now when I do this, it should move the piston and everything else accordingly. But we're going to see. To get it closer, I'm going to go ahead and pull this. Let's rotate this actually. Oops, that's the pin. Okay. And then joint. We're going to joint. Again, we're going to use this middle point of this axis, right? If you have trouble selecting that middle point like I am right now, you can always switch over to using between two faces. Select that face, and then the snap plane, like that. Boom. Okay. And then we'll do the same thing between two faces. And I'll use the outside. Right, outside or inside, it doesn't matter because it's all going to be centered. So between those two faces, the mid plane, and along that axis gives me that point. Like so. Okay, and we'll hit OK. Boom. And you can see it's now moved it into position, and we'll just slide this down so that it's not going through the body. Okay. And you can see the cap is kind of not in the right place. We're going to fix that in a second after we finish adding the pins and everything else. So for this one here, I need the long pin. I'm going to bring that in, move it out of the way, and just like every other time, we're going to joint it using that and that. Now, it went in backwards, obviously, so I'm going to unflip it and hit OK. Good to go. So that I can see what's going on inside, I'm going to go ahead and insert a section analysis plane. That'll help us see. I don't want to cut too far into it. I just want to be able to see through that chamber, so I'm going to leave it right there, like so. Okay, so now you can see we've got this guy moving. Unfortunately, for whatever reason, this is uncoupled. So we want to make sure that our piston head goes back to being locked together. And we'll move it back into position like so, and then capture the position. And we can go ahead and turn on contact. All right, so we've moved the piston head and handle all the way down into the assembly, like that. And we've captured the position. So now we're going to go ahead and turn off the analysis, like that. And save it. And then we're going to switch over to the simulation environment. So again, what we're going to simulate is with the piston pump in its downmost position for the piston head or upmost position for the handle. If you were to keep pulling on that handle, when would it break? So that'll be a static stress simulation. We've already assigned ABS plastic to this. So then we're going to just do a couple things. First, we're going to add the load. And the load we can put effectively on these faces as if you're gripping onto it and that's where you're pulling. And we'll say we're pulling up with 10 pounds of force. So decently strong pull. Okay. We need a constraint for this. So since it's as far away as possible, we're just going to constrain the bottom here, saying that this bottom face is fixed. Maybe it's attached to a hose, maybe it's affixed permanently on some other material, doesn't matter, but we need one constraint at least, and we'll use that. Okay. All right, and now we're going to establish our contacts. So we want this to simplify the simulation. We're going to assume that any two parts that are within a millimeter of each other are effectively rigidly joined. They're in contact, if you will. And now we can generate our mesh, like so. All right, there is our mesh generated. And the last thing we do is solve it. So we go down here to the solve menu, hit solve. I'm going to do this locally because I'm working on a desktop computer that's decently powerful. I'll hit solve and we'll wait for it to come back. Okay, so you can see the results have come back. And right now this is showing the safety factor, which takes into account a number of different things. We can also look at stress, how far things have displaced, right? Reaction force, strain, etc. on this. We are interested in safety factor, of course, and with that amount of force, this design, and again, this design was made out of ABS plastic. We have some weak spots here and here around the handle that are likely to break. And as I showed in part A of these videos, that is actually where the pump broke when we took it to failure in real life. So that is it. I hope this design process has helped you understand how to make a water pump using just 3D printing and Fusion 360. Take care.